Alright guys, welcome back. We're going to be continuing our lesson on radicals, and for this video we're going to focus on simplifying radicals. Now we've done this before, but we're going to review. Okay, so the square root of a number which is not a perfect square will be an irrational number. Now remember, irrational numbers are numbers that cannot be expressed as a fraction or a ratio. Decimal does not repeat or terminate. Most common one you're familiar with is pi. We would also be like square root of 2 or square root of any non-perfect square. We can estimate a square root by deciding which two whole numbers it falls. Now remember, whole numbers are your numbers greater than or equal to 0 that are not decimals. So you're counting numbers in 0, not your negative integers as well, because remember, in the real number system, the squares do not have negative. You can't get to, there's no negative perfect square in the real number system. All right, so we're going to do a little estimation, mark a few of them. So for example, the square root of 2 now is between what two whole numbers? Now 2 is is non-perfect square between the perfect squares 1 and 4. So square root of 2 is somewhere between the square root of 1 and the square root of 4. So the square root of 1 is 1, and the square root of 4 is 2. Now, of course, your square roots can be positive or negative as well, because a negative times a negative is a positive number. For now, we're going to focus on the positive square roots. All right, so the square root of 82 is between what two whole numbers? So remember the way we're going to figure this out is figure out the two closest perfect squares. Of course, 81 is a perfect square and is really close to 82. And then we have 64, which is a perfect square, and that's the one below it. Square root of 64 is 8, and square root of 82 is 9. So we can continue working these out this way. I'm not going to handwrite every single one of them. I will be just narrating them. All right, so the next one, square root of 20 is between what two whole numbers? Well, we have the square root of 25, which is the one above it, and that's going to be 5. The one below it is 16. Square root of 16 is 4. So it's going to be between these two whole numbers. All right, so the square root of 12 is between what two whole numbers? Okay, so we have square root of 9, which is 3, and square root of 16, which is 4. So you can follow the same pattern for all of the rest of these as well. So square root of 8 between 3 and 2. And I actually find that the easiest way to do this is just to figure out what's the one right above it or right below it, depending on if it's close to one that you know. So for example, 56 we know is greater than 49 and less than 64, so 7 and 8. 29 is really close to 25 and it is higher than 25, so 5 will be our lower number. And then the next one is 36, so 6. Now sometimes it will ask us for the square root of a non-whole number. So 1/4, the square root of 1/4 is 1/2. But we know that 1/4 is between 0 and 1. 0 squared is 0 and 1 squared is 1. So it's between 0 and 1. Same for 5/2. 5/2 is 1.5. So it's going to be more than 1 and less than 2. All right, we've got 40. Now 40 we know is close to 49, but it's less than 49, so we're going to put square root of 7. And then so below that is 36. 99 is very close to 100, so its square root of 100 is 10, and so therefore the lower number is 9. And then we have the square root of 50. 50 is just a little over 49, so the lower number is 7. And then the next one would be 8. Now it does want us to put it on the number line as to where it goes. I don't really think we need to worry about that right now, but the online version of the notes will have that information there as well. All right, so we're going to write the decimal approximation for each indicated place value. What this will do, the reason we were doing the previous part where we were estimating which one it would be between, is to make sure our decimal approximation makes sense. So we have the first one is square root of 40. Now we had decided that was going to be between 6 and 7. So it's going to be 6 point something. Okay, so that's something we can rely on. 6 point something. We don't know what that something is. So to find out what that something is, we're just going to run it through a calculator. All right, so according to my calculator that I'm using the one on my phone. Square root of 40 is 6.32455. And I'm just bringing that many decimal places so that we can see how far we need to round. So the nearest tenth, okay, so 6.32. 2 is less than 5, so our nearest tenth would be 6.3. And then we have 6.324 to round to the nearest hundredth. So that's 2 decimal places. So that's going to be 6.32. And the nearest thousandth is round to the third decimal place. So that would be 6.32. And then we need to figure out, do we want the 4 to go up or down? Well, the 5 is 5 or higher, so the 4 will go up. 6.325. Okay, so that is the square root of 40 with decimal approximations. Now we're going to do the square root of 2, which is a good one to know. Remember, somebody may or may not have died over the square root of 2. So the square root of 2, we know it's between 1 and 2, and my calculator tells me that it's 1.4142. I'm going to the fourth decimal place because the lowest we want around is the most precise number is the thousandth there. So nearest tenth, 1.4. Nearest hundredth, 1.41. And nearest thousandth, 1.414. Now, if you have any questions about why I'm rounding the way I am, please feel free to get in contact with me outside of the YouTube channel. You can email me or you can contact me through Google Classroom, and we will have a Google Hangouts this week to figure out if anyone needs any assistance. You can also leave a comment down below and I'll get to them as quickly as possible as well. Just make sure to let me know. All right, so square root of 66. 66 is between 64, which square root of 64 is 8. It's a little higher than 64, so we know it's going to be 8 point something. 64 is less than 81, so it's between 8 and 9. So let's see, what is the square root of 66? And my calculator says 8.1240. Those are just the first 4 decimal places. All right, so nearest tenth, 8.1. Nearest hundredth, 8.12. And nearest thousandth, 8.14. All right, 5 times the square root of 7. So we have to remember that we are going to be multiplying by 5. So let's see what the approximation for square root of 7 is. Okay, when I run that through my calculator, I get 2.6457, and we need to multiply it by 5. So if I multiply that by 5, I get 13.2287. It would actually round to 88, but we're going to round to the nearest thousandth as our most precise. So I just wanted to write down the first 4 decimal places. So nearest tenth, 13.2. Nearest hundredth, 8 is higher than 5, so 13.23. And then finally, nearest thousandth, 7th is higher than 5, so 13.229. All right, next one is 3 times the square root of 19. Square root of 19 is 4.588989435. I'm going to multiply that times 3, and it's going to be 7.5498. So this is going to be an interesting one. All right, so nearest tenth is easy enough, 7.5. Nearest hundredth, easy enough, 7.55. But nearest thousandths is going to be a little bit complex. So let's analyze this. Our nearest thousandths means we're going to analyze the 4th decimal place. It is higher than 5 or higher, so that means we're going to round up. When we round up to 9, it becomes 10. So that means we need to carry the 1 over here. So the 4-9 becomes 5-0. So our nearest thousandth is actually 7.550. And it is really important that you include that 0 because otherwise you've just attempted to round to the nearest hundredth. So notice how technically there isn't a difference in the value between nearest hundredth and nearest thousandth. Nearest thousandth is still more precise because it includes that 0. So make sure you are actually doing that. Do not forget. So we're going to practice evaluating some roots here. It says if the root does not exist, right, DNE does not exist. However, what we're going to do is put no real roots at this point. The reason we're going to do that is that it's not that the root does not exist, it's that the square root of these numbers would be imaginary, and we have not covered imaginary numbers. So instead of does not exist, we're going to write no real or no real roots. Right, so let's put no real roots. And that's the same as when we say no real solutions. Okay, so it means that the answer is not a real number. So what we have here is square root of 81. Actually, we could go ahead and do both positive and negative. So square root of 81 is 9 or negative 9, so positive or negative 9. Now we have the square root of negative 81. Now if it's a square root and the number is negative, we know that it is not real because they cannot have a perfect square that's negative. So what we're going to do is we're going to factor this as the square root of 81 times negative 1. And we can leave this either as no real roots or put plus or minus 9 times the square root of negative 1. Plus or minus 9 times the square root of negative 1. All right, so the next one we are looking for a 4th root. So what we're going to need to do is figure out how to factor 81 such that we get 4 of the same factor. So let's see what we can do. All right, so we're going to factor 81. Because we're looking for the 4th root, we're going to work on our prime factorization. So we're going to take 81 and divide it by our lowest prime number, which is 2. We can't actually divide 81 by 2 evenly, so we will go ahead and divide by the next lowest prime number, which is in fact 3. And 81 is definitely divisible by 3 because 8 plus 1 is 9, and 9 is divisible by 3. Anytime you can add the digits together and the numbers are also and the answer to adding the digits together is divisible by 3, then the result is divisible by 3. Okay, so 81 divided by 3 is 27. Let me write that down. All right, so then we're going to go ahead and divide that by 3 as well because 27 is divisible by 3, and that's 9 divided by 3, and then 3 divided by 3, or 9 divided by 3 is 3. And so our prime factorization, because 3 is also prime, is 81 is equal to 3 times 3 times 3 times 3. And we actually have 4 3's there, so that is actually quite useful to know. So that means that the fourth root of 81 is equal to the fourth root of 3 times 3 times 3 times 3. So the 4 tells us how many of them there needs to be alike. So we have 4 3's. And one student told me about how her brother's learning to simplify radicals via murder. So what that means is only one of these guys can survive. He cannot leave the house unless he kills his partners. So in this case, we have 1 3, and he is going to kill the other 3 3's. So the fourth root of 81 is 3. Okay, so our next problem is square root of 16 divided by square root of 64. This is pretty simple. I didn't want to factor it out here, but for the fourth root of 81, but this is simple enough. Square root of 16 is 4. Square root of 64 is 8. And so the answer to this would be plus or minus 1/2. Positive or negative. Square root of 25 is positive or negative 5. That's one of our perfect squares. So we have the square root of 400, which is 20, divided by the cube root of 125. Well, let's find out what the cube root of 125 is. All right, so we're going to use the same process that we did with the prime factorization of 81. So we're going to look at 125. Is 125 divisible by 3? It's not divisible by 2 because it's not even. 2 plus 5 is 7 plus 1 is 8. That is not divisible by 3, so it's not divisible by 3. So 125 ends in a 5, so therefore it is divisible by 5. And so 5 into 125, 5 goes into 12 twice. And we bring down our 5. All right, so 5 goes into 25 5 times. 5 times 5 is 25. And that's 0. Okay. So then 25 is divisible by 5, and we get 5. So we have the cube root of 125 is equal to the cube root of 5 times 5 times 5. So in this case, we have a pair of triplets because it's a 3. We want the triplets and only one can survive. So this 5, in order to get out, has to kill these 2 to get rid of them. And so the cube root of 125 is 5. But that didn't ask us what the cube root of 125 was. It asked us what the square root of 400 divided by the cube root of 25 is. So let's go ahead and figure out what that is. Okay, so we get 20 divided by 5. 20 divided by 5 is 4. So the answer would be plus or minus 4. Now, something you may have noticed is that I'm only doing the plus or minus on the square roots. That's because for the cube roots, the sign will always be the same as the radicand. All right, because -1 times -1 is 1 times -1 is -1. So the cube root will always get the same sign as the radicand unless there's something outside of the radical telling us otherwise. All right, so we have the cube root of 8. This is one of our perfect cubes. We know it's going to be 2. Cube root of -8 is -2. And it's because, remember, 8 is 2 times 2 times 2. And -8 is -2 times -2 times -2. Right? But square root of 8. We cannot square 8 is not a perfect square. And it is negative. So this one would still be does not exist in their terminology that they've given you, or no real roots. Just like this square root of 81 was no real. But we're going to go ahead and factor it so it looks a little neater. So we get square root of -8. All right, so we have the square root of -8. Now we're going to factor 8. So first thing I'm going to do is I'm going to have -1 times. So that way we have -1 times 8. And then we're going to factor 8 into its prime factorization. And because we are looking for perfect squares, we want it in 2's. So it's going to partners will murder each other. And I'm going to do both the prime factorization and standard factorization. So we have 8 divided by 2 is 4, divided by 2 is 2. So 2 times 2 times 2. So again, we're looking for pairs. Here's a pair. One kills the other and can exit the house. So we get 2 times the square root of -1 times 2, which is -2. The other way we can do that is to factor 8 into its various factors and look for the perfect squares. If you're good with perfect squares, this way is actually faster, especially when you're dealing with larger numbers. So we get 1 and 8, 2 and 4. 4 is a perfect square. So we can make the factorization as -1 times 2 times 4. 4 is a perfect square. So the square root of 4 is 2. And then still times the square root of -2. So the answer is the same. Strategy just differs a bit. All right, up next is the fifth root of 32. So we're going to go ahead and factor that as well. So to be perfectly frank, I don't actually know what the fifth root of 32 is off the top of my head. I do know how to find out the fifth root of 32. But since most people aren't going to know their fifth exponents, 1 to the fifth, 2 to the fifth, 3 to the fifth, 4 to the fifth, most of us don't know those off our top of our heads. Exponents are squared and are cubes. Those ones a lot of people will know a lot of, but fourth and up, it's kind of hard to do. So we're going to do our prime factorization of 32, and we're going to look for sets of 5s because it's a fifth root. So we have 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So now we've got 2's going all the way down. So we have the fifth root of 2 times 2 times 2 times 2 times 2. That's 1, 2, 3, 4, 5 2's. So this 2 gets to come out, but on the condition that the other 4 die. So we have the fifth root of 32 is equal to 2. Nothing else is left inside the radical, so our answer is going to just be 2. Okay, so the next one's going to be a multiple step one as well. Square root of 36 is 6 plus 1, which is the cube root of 1. So the thing is remember, square root of 36 can be positive or negative. So we have 6 plus 1, which is 7, and -6 plus 1, which is -5. Make sure you pay attention to that right there. All right, so the eighth root of 1, well, any root of 1 is 1, because 1 times 1 times 1 times 1 times 1 times 1, etc. is 1. So go ahead and make sure you keep track of that. All right, So number 2 is the square root of 2 times the square root of 225. And 225, let's see. 225 is one of our perfect squares, which was on our previous video. So it's going to be 2 times square root of 25 is positive or negative 15. So 2 times negative 15 is negative 30. 2 times positive 15 is positive 30. So your answer is going to be plus or minus 30. 900 is also a perfect square. It is 30 times 30. And so again, remember plus or minus. Plus or minus 30. 3 times the square root of 100. Okay, so it's going to be 3 times square root of 100 is plus or minus 10. All right, so again, our answer for the third time in a row is plus or minus 30. That was not meant to be a trick. It just happens sometimes. All right, cube root of 1,000. 1,000 is one of our perfect cubes. It's 10 times 10 times 10. So the cube root of 1,000 is 10. And again, remember for cubes, it's going to be the same sign inside. All right, so for the cube root of negative 0.027, we're going to actually just run that one through the calculator. It's a little annoying. We know that the cube root of 27 is 3, so we know there's going to be a 3. And the cube root of 127 is negative 0.3. And you might be wondering, well, why are there so few decimal places? Well, let's just remember if we multiply 2 decimal places together, the resulting answer has the same number of decimal places. So same thing if we multiply all 3 decimal places. So 0.3 times 0.3 times 0.3. That's 1 decimal place here, 1 decimal place here, 1 decimal place here. 3 total decimal places, 3 total decimal places in the results. Right? Moving right along. We have the square root of 144 over the square root of 121. These are both perfect squares, so plus or minus 12 over plus or minus 11. And that does work out to where the final answer is positive or negative 12 over 11. Right? 6 minus the square root of 49. The square root of 49 is positive or negative 7. And I'll put that in parentheses because we have a negative or minus in front of it. 6 minus negative 7, minus minus. Remember that's a double negative, so that's positive. So it's going to be 13. 6 minus positive 7 is negative 1. Make sure you do both answers. All right, so the next one we have is negative 6 times the square root of 49, and that's positive or negative 7. So negative 6 times positive 7 is negative 42. And negative 6 times negative 7 is positive 42. Right, so we get positive 42. Positive or negative 42, sorry. All right, point 4. So we know the square root of 4 is 2. Let's figure out our decimal place. There's 2 decimal places, 2 numbers. So we get 0.2 times 0.2. So the square root of 0.4 or 0.04 is positive or negative 2. Positive negative 0.2, sorry. 36 minus 9. Square root of 36 minus 9. Now this one, because there's a subtraction, there's going to be several different answers we need to make sure we're prepared for. So plus or minus 6 minus plus or minus 3. So we're going to do this one at a time. Positive 6 minus negative 3. That's 9. Positive 6 minus positive 3 is 3. Negative 6 minus minus positive 3 is negative 3. And negative 6 minus negative 3 is -9. If you want a more efficient way to write this answer, you would do it positive or -3, positive or -9. All right. Okay, so the next one is the cube root of -1 over 64. We're going to do the same way we did with the fractions for our square roots. All right, so it's going to basically be the cube root of 1 over the cube root of 64. And it's negative, so it doesn't actually matter. All right, so -1 cube root is -1. And then the cube root of 64. So 64 divided by 2 is 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. 1, 2, 3, 4, 5, 6. 6 twos. So cube root, and we 2 times 2 times 2 times 2 times 2 times 2. So remember, the first in each trilogy, or in each trio, survives. So this 2 will come out. And this 2 will also come out. But remember, to get out, they have to murder the other members of their group. So 2 times 2 is 4. So the answer is -1 over 4. -1 over 4. -1 over 64. Again, negative square roots do not really exist, so no real roots. For now, we can also say, so what's the square root of 1 over 64 would be 1 over 8 times the square root of -1. And then we have the fourth root of 0. Any root of 0 is 0, because anything times 0 is 0. So you're going to have 0 times 0 times 0 times 0 forever and ever and ever. It'll still be 0. Sometimes we will need an exact answer, an exact value. When that happens, and our radicand is not a perfect square, perfect cube, perfect fourth root, whatever we're looking at, the best we can do is simplify, right? So it's actually better to know how to do this. A fully simplified radical expression has no perfect root factors, either again square or cube are most common. We'll rarely do anything else. So again, there are two methods for factoring or simplifying radicals. One is to use perfects, and one is to factor to primes. So we've been using both of these methods in this video, but you can use whichever method works better for you. The higher the number, the more likely it is that this method, method number 1, will be more efficient because prime factorization for big numbers is really tough. So 20, let's do square root of 20. 20, let's do our full factorization, is 1 and 20, 2 and 10, 4 and 5. And so what we're going to do is find our perfect square. 20's not, 10's not, 5's not. So I go down and around. Start at the top and work your way down. 4 is. So the square root of 20 is the same thing as the square root of 4 times 5. You can break it down into the square root of 4 times the square root of 5. And the square root of 4 is 2. Square root of 5 cannot be simplified, and so the answer is 2 square root of 5. All right, so let's do that one with prime factorization. Again, we use the birthday cake method. So 20 divided by 2 is 10. 10 divided by 2 is 5. Those are all prime numbers. So square root of 20 is 2 times 2 times 5. And remember, we're going to take any pair or Any grouping, remember the whole group goes together. One of them comes out and the other one dies. So 2 is going to come out and the other 2 dies. So we get 2 square root 5 as our answer as well. So again, it doesn't matter which method you use so long as you know what you're doing. All right, so let's do perfects for method number 1 for square root of 200. All right, so 200 is 1 and 200, 2 and 100. Now, I already have a perfect square here. I can stop. So the square root of 200 is the square root of 2 times the square root of 100. The square root of 100 is 10, and square root of 2 stays the same. So it is plus or minus 10 square root of 2. And to be honest, this one should have been plus or minus as well, as should have that one. All right, so again, let's do it with prime factorization. Again, not my preferred method here, but we'll do it anyway. So 200 divided by 2 is, or 200 divided by 2 is 100. Divided by 2 is 50. Divided by 2 is 25. And then that's 5 by 5. Divided by 5. All right. Sorry, threw myself off there for a moment. So the square root of 200 is the square root of 2 times 2 times 2 times 5 times 5. 2 5s, 3 2s. Okay. And we're looking for pairs because this is square root. So here is a pair and here is a pair. So again, one murders its partner and comes out. Again, with the 5s, he murders his partner and he comes out of the radical. So we get 2 times 5 times the square root of 2. So our answer is again plus or minus 10 times the square root of 2. All right, moving right along. All right, so square root of 48. I'm going to do the main factorization, looking for perfect squares. 48 is 1 and 48, 2 and 24, 3, yeah, it's 3, and 16. And again, there's my perfect square. So square root of 16 times the square root of 3. I do like to put the perfect square in the front because it's where it's going to end up. Square root of 16 is 4. Square root of 3 is square root of 3. So plus or minus 4 times the square root of 3. Again, we can do that with our prime factorization as well. 48 divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So what we're going to end up with is 2 times 2 times 2 times 2 times 3. Here's one pair. Here's another pair. Remember, only one can come out and the other one dies. So we get 2 times 2 times square root of 3, or again, plus or minus 4 times the square root of 3. All right, square root of 63. 63 is 1 and 63. It's not divisible by 2. 3 and 21. Not divisible by 4 or 5. So 6, 7, and 9. And 9 is our perfect square. So it's going to be square root of 9 times square root of 7. Square root of 9 is 3. And square root of 7, right? So plus or minus 3 square root of 7. Again, we can do a prime factorization. 63 divided by 3 is 21. Divided by 3 is 7. And so it's 3 times 3 times 7. 3 times 3, that's our pair. One of them dies and the other one comes out of the house. And 7 stays the same. Plus or minus 3, square root 7. Almost done. We're just going to talk about how to simplify our cube roots. Again, same thing, method 1 on the left. So we're going to factor 54. That's 1 and 54, 2 and 27, 3 and 18. Sorry, 5. It is divisible by 6 and 9. And then we would be wrapping back around here. So here is our perfect cube. This does require you to know your perfect cubes. So the cube root of 54 is equal to the cube root of 27 times the cube root of 2. And I wrote fourth. Oops. Let's fix that. All right, cube root of 27 is 3 times the cube root of 2. So 3 cube root of 2. It's very important that you make sure your index is inside the v of your radical, or else it might look like you're saying 33 times the square root of 2. So possibly put your coefficients in parentheses, put your radical expression in parentheses, whichever one works better for you. All right, same thing over here for prime factorization. It's the same concept. 54 divided by 2 is 27. 27 is not divisible by 2, so 3 is 9. Divide by 3, divide by 3. And again, we're going to get cube root of 3 times 3 times 3 times 2. Here's one set of 3's. So remember, one murders the rest of their group to get out. And we get 3 times the cube root of 2. And make sure your coefficient is visually distinctive from your index. If your coefficient is not visually distinctive from your index, it will get counted wrong because that will look wrong. So it has to look right for these. So whatever you have to do to make sure I can tell that there is something between the 3 and the index, okay? All right, last one. All right, last one is the cube root of negative 24. Now we know our answer is going to be negative, so we're just going to factor 24. Let's work on our 24. So that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. And it's not divisible by 5, so we know we're going to wrap back around, and that's going to be the same numbers. Our perfect cube is 8. So the cube root of 8 and negative 8 times the cube root of 3. And I'm just going to bring the negative out with the one that's going to be the coefficient. Okay, the negative should go in front of the coefficient. So the cube root of negative 8 is negative 2 times the cube root of 3. And notice how in this one, I put the radical expression in parentheses, but there is something that makes it show that there is a distinction between that coefficient and that index. It is important that you write it. If you are not clear, I'm going to tell you again, if you are not clear about which of these numbers is the index and which is the coefficient, it will be marked wrong. You need to make sure you're careful with that. So the other strategy, again, we know our answer is going to be negative, so I'm just put a negative out in front. Prime factorization, 24 divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So it's cube root of 2 times 2 times 2 times 3. And we have a group of 3. Remember, the first one comes out by murdering the other 2. So 2 cube root 3. And we know it's negative, so negative 2 times the cube root of 3. Alright, so we're going to wrap this video up right here. Make sure you pay attention because I will be putting out the next video, which will be simplifying radicals that have variables in it. And that will be all the information you'll need for the first assignment that you have on Google Classroom. So make sure you practice through these. If you have any questions about the example problems that are online, they just have the answers. Give them a try, see how you do with them. But if you have any questions about how to do them, just go ahead and let me know. You can email me, you can message me on Google Classroom, and again, we will have a Google Hangout session set up probably for Thursday in the afternoon for this week. I will post that to Google Classroom as soon as I can. All right, see you later, guys. Bye.